pressure, high temperature in a thermal expansion valve, high pressure, high temperature liquid refrigerant is converted into low temperature, low pressure saturated liquid plus vapor mixture. This is because of an orifice present inside a thermal expansion valve which regulates the flow. And this refrigerant is now passed through the evaporator. In evaporator, it absorbs the heat from the environment and converts completely the mixture of and it converts the mixture of saturated liquid plus vapor into the vapor state, and now it is in a superheated state when it comes out of the evaporator.
It is not in
And
superheated state. Who told it will be in superheated state? It is not in superheated state. In a saturated liquid plus vapor refrigerant enters into the evaporator and it absorbs the heat from the refrigerated space, and saturated liquid plus vapor refrigerant will be converted into the vapor refrigerant. Then it is sensed by sensing bulb. This much only you have to tell.
superheated, that's not required.
No, superheated it will not become also. In the VCRS graph,
It
no.
will be saturated. It will come
Yeah,
out as saturated vapor.
saturated vapor it will come out, but you should not tell saturated vapor also. I told you, no, in onboard ship sometimes they will heat the
Ah,
refrigerant to 3 to 4 degrees superheated, but you don't mention in the interview this one. Okay. Yeah, in the VCRS graph, from saturated vapor only you will take the line upwards, no, compressor. You saw, no, that pH curve.
yeah, that one. pH
Straight.
and TS.
TS curve. In that, it will from saturated vapor curve only it will go upside.
Direct, it will go up.
But you will heat it. Means if you heat, no, efficiency will increase. Because of that we will heat. But don't tell that. Means saturated liquid plus vapor refrigerant enters into the evaporator. It will absorb the heat from the refrigerated space. Then saturated liquid plus vapor refrigerant is converted to the vapor refrigerant. Then it is sensed by the sensing bulb. Avek answer you tell.
Sensing bulb. The sensing bulb, it senses if the temperature of refrigerant coming out of an evaporator has is not up to the maximum or minimum. All I forgot.
If you want to start from starting, you will tell. It will be fine.
From first means
Compressor,
before
sir. Compressor.
compressor.
Start.
The low pressure, low temperature, dry saturated. I should not say that,
Hmm. Yeah, tell.
or else I'll do one thing.
You will study
Huh?
this the next day.
I'll study this then because
Okay.
I've studied in other manner. So now it will get confused. Again, I
Okay,
will
okay.
study from
You
first.
you prepare the answer again, and then you
Uh,
practice that. Then again I will take sometime else. Okay. Then safety devices of refrigerator. You know.
Safety devices used in a refrigerator are LP cutout, HP cutout, low pressure lube oil cutout,
Hmm.
uh, bursting disc used in between the intake and exhaust manifold, bursting disc used in a condenser, a
Hmm.
compressor, bursting disc used in a condenser, compressor, bursting disc used in a compressor, relief valve, solenoid valve, oil heater,
Hmm.
liquid shock wave.
Hmm. Wait 1 second. Uh, can you name again?
LP cutout,
Hmm.
HP cutout,
Hmm.
lube oil low pressure cutout,
Hmm.
bursting disc used in between intake and exhaust manifold,
Hmm. Hmm.
bursting disc used in a compressor,
Bursting disc only you
re-
tell. Compressor means like a bursting disc is used in compressor
ah,
only, not anywhere else. Only in compressor,
okay.
VCRS only compressor we will use the bursting disc. Okay. So just name it as bursting disc. That's it. Okay. Don't tell used
Okay.
in there or that. Bursting disc. Then.
Relief valve, solenoid valve,
Hmm.
oil heater,
Hmm. Hmm.
uh, yes,
Yeah. This much also is enough. Okay. But don't tell wrong. Bursting disc
yeah,
only you tell. It is not. Bursting disc is not used in condenser. Okay, pressure relief valve is used in a condenser. Bursting disc is used in a compressor. Okay, then don't confuse it. If you don't remember, just tell bursting disc, pressure relief valve, over. That much.
Okay.
Okay, and master solenoid valve, if you remember, you can tell. Means everything you have to tell, no, nothing like that. Any six you tell. But if I ask in between, means explain that, explain this, no, you should be able to explain everything. Okay, can you
Okay.
explain everything? Whichever
Yeah,
you
I can.
list. Okay, explain.
Everyone,
Everything,
everything.
everything.
Uh,
He can ask
LP
anything.
cutout.
Means like he asked manual something. He listed six and he asked one of them. So if you list the six, no, whatever you will list, no, from that only he will ask explain one of this, like that. So explain. You be ready to explain everything. Okay.
LP cutout.
Hmm.
LP cutout senses if the suction of the at the compressor is below the minimum value. HP cutout is used if the pressure that is released in the by the compressor
Hmm.
is above the maximum value, which might damage the other parts of the refrigeration system.
What will
Then comes
happen if it pressure is less than that value? It will trip. If what will happen if the pressure is more than that particular value? It will trip.
it will trip.
You
Hmm.
should tell it will trip, like that. Then next.
It low pressure lube oil trip.
Hmm.
Low pressure lube oil low pressure lube oil cutout.
Hmm.
In this, if, when the pressure of a lube oil is below the minimum value,
Hmm.
the lube oil cannot be reached to the moving parts of a compressor. Hence, it might cause a seizure.
Hmm.
Therefore, there will be a trip taking place.
Hmm.
Bursting disk. When the pressure when the pressure exerted is more than the maximum value, the bursting disk will burst and the operation taking place will be stopped.
Hmm. Yes.
Solenoid master solenoid valve.
Hmm.
Master solenoid valve is used before the evaporator, which helps in regulating the flow of refrigerant whenever the refrigeration process is required.
Hmm.
Mm,
Then relief valve, pressure relief valve in condenser.
Pressure relief valve. Pressure relief valve is used when the pressure exceeds the when the pressure exerts the maximum value. It will
It will release the pressure.
it will relieve the pressure.
Hmm. Master. Then auxiliary engine safety devices.
The auxiliary engine safety devices are uh, jacket water, high temperature trip and alarm, lube oil low pressure trip and alarm, uh, exhaust gases high temperature alarm, motor high speed trip,
Hmm. Motor high speed trip. Huh?
uh, motor motor
Over speed trip.
over over speed trip.
Hmm.
Then
Crankcase relief valve you told.
crankcase relief valve.
Hmm. This much only. Can you explain all?
Uh, Little bit.
Yeah. Tell.
When the heat that is transmitted to the cooling jacket water is more than the desired temperature, it will sense and alarm the it will give an alarm, and if it if it exerts more than the maximum level, then there will be a trip taking place.
Hmm.
High temperature exhaust gas trip.
Yes.
When the when the exhaust gases temperature are more than the minimum limit, there will be trip taking place, as it will indicate that something wrong is going on inside the engine, which which is why the exhaust gases are giving high temperature. Therefore, a trip will take place. Crankcase relief valve trip.
In a
high temp
high temperature exhaust gas, no, there will be no trip. There will be alarm will be caused. Okay. You study this everything. Means like where alarm is going to take place, where trip is going to take place. Once you see and study that, and next you can tell next after exhaust gas. Crankcase relief valve it is called.
crankcase relief valve
Hmm.
trip. In crankcase relief valve, when the pressure inside the crankcase is more than the maximum value, the crankcase relief will trip. That means we'll have to remove the pressure from the crankcase
Hmm.
by opening the valve.
Hmm.
Which one is left?
Then overspeed trip you told.
No, overspeed trip.
Hmm.
When the motor absorbs more current and it runs in high speed rather than the normal speed, there will be a motor high speed trip.
Hmm. Will be taking place. Okay. Then after that, compressor safety devices, you know.
Compressor safety devices.
Yeah, tell me.
But some of the compressor safety devices are bursting disc,
Hmm.
lube oil low pressure trip,
Hmm.
water high temperature trip, water no flow trip,
Hmm. Motor overload trip
motor overload trip,
and
and
fusible plug.
fusible plug.
Hmm.
Moisture drain, that is not.
Hmm. No. Okay, can you explain all?
Mm.
Okay. Otherwise, will you practice
I'll
tomorrow?
practice
Next
that.
time, can you explain? Okay.
Yeah, okay.
Can you tell Faraday's law?
Faraday's law states that when a conductor is placed in a varying magnetic field,
Mm-hmm.
electromotive force is generated,
Mm.
and when the conductor place is of closed circuit, the the current produced will be of induced current.
No. Whenever magnetic field is linked with the circuit changes, EMF will be induced. That is the Faraday's first law. And second law is induced EMF is directly proportional to the rate of change of magnetic field. So this is the second law. And second, if you tell in other way also it's fine, but the meaning should be same. But in the second law, your meaning is different. So you study
Second
this.
law I didn't say.
Sir, second law you didn't say. Okay.
Uh,
Okay.
I
Tell.
was in the two sentences there, right?
Okay. Okay.
First law.
Okay. Tell.
Second law states that the magnetic the EMF induced by a magnetic coil is directly proportional to the change in the magnetic flux.
Yeah, this is
Is it
proper.
correct?
It is
Uh,
correct. First law only you tell again.
First law, 1 minute. Half I said.
From starting you tell. First law.
First law states that when a conductor is placed in a varying magnetic field,
Hmm.
EMF is generated, and if the conductor is of closed circuit, the current produced is called as induced current.
Huh. Okay. Correct. Correct. And Lenz law, you know.
Uh,
Tell.
Lenz law states that polarity of induced EMF is such that it opposes the change in the current, and it polarity of induced EMF is such that it opposes the change in current, and electromagnetic force is in the opposite direction.
Hmm. Okay. This is proper. And Archimedes principle, you know. Yeah. Tell.
Archimedes principle states that when a body is wholly or partially immersed in a body, the body tends to be
In a
lifted up by
fluid.
in a fluid.
Hmm.
The body is lifted up by upward force, which is equal to the weight of the water displaced,
Hmm. And the force is called
and
as.
buoyant force.
Hmm. Yeah. And Archimedes principle over no Bernoulli's principle, you know.
Bernoulli's principle states that for a perfect incompressible fluid moving in a continuous stream, the energy is equal at every point of the pipe.
Hmm. Okay. Bernoulli's principle once you check. I don't think it is up to the mark.
For a perfect incompressible liquid,
Hmm.
the flow of a liquid moving in a continuous stream is equal at every point of the pipe. Is same at every point of the pipe.
What is this law?
Bernoulli's principle.
This is Bernoulli's principle. Tell Pascal's law.
Pascal's law states that for a perfect incompressible liquid in a confined space, the when the pressure is applied, it is equally transmitted in all direction.
Hmm. Yeah, this is proper. Boiler mountings, can you list out the boiler mountings? Yeah, tell.
Boiler mountings are pressure relief valve, safety valve, water level indicator, blow down cock, feed check valve,
Hmm.
fusible plug,
Hmm.
air vent cock, scum valve,
Hmm.
steam stop valve,
Hmm.
low water level indicator.
Hmm. Can you explain
Both
all?
I should say
What?
fusible plug and low water level indicator.
Yeah, you tell both. Can you explain all?
Safety valve is used. Safety valve is used in a boiler when the pressure exceeds the maximum level. The safety valve will stop the firing operation taking place inside the boiler,
It
and hence the
releases the pressure, right? Safety valve.
safety valve.
Hmm.
Yeah.
It releases the pressure. It will not stop the operation.
uh,
Okay. Then next one.
Safety. There are two safety valves present in the boiler that I left to add.
Okay. You can
Uh,
tell that. Next one.
Water level indicator.
Tell.
Water level indicator is present at the front of the boiler. It indicates the water level inside the boiler,
Hmm.
and from this we can understand whether the boiler water level is below the minimum level.
Hmm.
Safety valve, water level. Pressure relief valve.
Hmm.
In a uh, in a pressure relief
Pressure relief valve is there.
is not there.
Then feed check
Pressure
valve is
gauge.
there.
Pressure gauge.
Okay.
Pressure gauge is there, right?
Yeah, pressure.
Pressure gauge. Pressure gauge indicates pressure gauge indicates the pressure inside the boiler of the steam. If it exceeds the
No, it
only
will
that much is enough.
only it will indicate. It
Only
will
indicate.
nothing it will do. And Borden
Feed
type of
check
the pressure
valve.
gauge we will use. It's like a special type it is.
Which type?
Borden
Borden.
tube,
Borden.
Borden tube pressure gauge. In my PDF you saw, no, it is there everything.
Yeah, it's there.
Okay.
Borden type of pressure gauge.
Borden tube pressure gauge.
Borden tube pressure gauge.
Hmm. Then next
Feed
one.
check valve.
Feed check valve.
Feed check valve.
Yeah.
Uh, Feed check valve is a non-return type valve which only allows the water to flow from the water source into the
Hmm.
boiler whenever required.
Hmm.
Steam stop valve.
Hmm.
Steam stop valve is also a non-return valve which helps in transporting the steam from one point to the
Hmm.
other point where it is necessary.
Hmm. Hmm.
Fusible plug. Fusible plug is present at the top of the crown.
Hmm.
When the water level goes below the minimum level,
Hmm. Hmm.
the fusible plug gets heated and it gets burned.
Hmm.
Therefore, the firing operation is stopped.
Hmm. Yes.
Then scum valve.
Hmm.
Scum valve is used to remove the floating debris present in the boiler on top of the water surface.
Hmm.
Next is a air vent cock. Air vent cock is used
Floating debris in present in the steam drum. It is also. You should
steam
also
drum.
mention that it is present in whichever dirt will be present in steam drum. No floating debris. It is removed. In the
Okay.
steam drum, you have to mention. You missed that. Okay.
It is present in a steam drum.
Yeah. Okay. Next.
Then air vent cock.
Huh.
Air vent cock is used in order to avoid implosion due to the depressurization of the depressurization of the charge inside the boiler.
Hmm.
It is also used when the water is added into the boiler. There will be oxygen and the carbon dioxide inside the boiler, and this will cause serious corrosion taking place inside the boilers.
Yes. Then next.
Uh, Finished. Right?
Okay. Air vent cock and this one you tell boiler blow down valve you didn't tell.
Boiler blowdown valve.
Yeah.
When the boiler operation is completed, it is used to remove the sediments, mud or scales present at the boiler base, which is left out
Water drum. This boiler blow down valve
at
removes
the
the debris and all in water drum. Scum valve
water drum,
remove from the steam drum.
steam drum.
Hmm. You have to mention this. Okay. And fusible plug you told, no? Then anything left? Low water level shutdown, you told
That
also.
I told.
Okay. Steam stop valve, you didn't tell.
I told.
Told, huh? Okay, tell
After
what it does. Steam stop valve.
steam stop valve is a non-return type of valve.
That feed chuck valve is a non-return type, no?
This is also non-return type valve. Right?
Okay,
Those
okay.
two are, I don't know. I think it is non-return one.
Okay, okay. You tell me what it does.
Uh, it helps in transporting
Yeah, both
the
are,
steam.
yes, correct. You both are a
uh,
non-return type of valve. Correct.
steam stop.
Uh,
It helps in transport. It helps in stopping the transporting of the steam to the necessary operation places when the necessity is completed.
hmm. And it avoids the steam hammering also. This is important.
Steam
Steam stop valve ka main function is steam hammering. It will if you do not open the steam stop valve, suddenly it causes the steam hammering. You have to tell.
like is it like this steam stop valve should be closed very slowly, like
Yeah,
suddenly we should
yeah,
not
yeah.
close. That I have to tell.
Suddenly if you open, no, then it
uh,
will cause the steam hammering. Means like you
uh,
slowly, you don't mention that it will avoid the steam hammering करके you tell. If you tell this much also, no, it is fine. He wants to hear the function. Main function of the
oh,
steam stop valve is to avoid the steam hammering. Okay. Okay. Then what is NDT methods? You know NDT, non-destructive testing
NDT
method.
methods.
Yeah, tell me everything.
Some of the NDT methods are magnetic particle methods,
Mm-hmm.
ultrasonic inspection,
Mm-hmm.
visual inspection, dye penetration method,
Mm-hmm.
thermal inspection,
Mm-hmm.
acoustic emission,
Mm-hmm. Acoustic. Okay, explain everything.
everything.
Yeah, means he can ask anything, bro. So.
Uh, magnetic particle inspection. Magnetic particle inspection is a type of NDT method in which the required material which has to be inspected is energized with the electric current with the help of permanent or temporary magnets.
Mm-hmm.
Once the part is energized,
Mm-hmm.
the magnetic particles are sprinkled
Mm-hmm.
around the place where we need to test,
Mm-hmm.
and it will provide a magnetic field in various forms. Now we can understand whether the defect is present or not on
Mm-hmm.
the workpiece.
Mm-hmm. Then next one.
That is ultrasonic inspection method. In ultrasonic inspection method, high frequency sound waves are used in order to find whether the material is free from cracks, flaws, or defaults. When this high frequency sound waves are imparted on the workpiece with the help of an emitter, it hits the workpiece, and it is reflected back, and the duration at which the sound waves hit the workpiece and is absorbed gives us the idea about the type and the nature of the defect.
Mm-hmm.
Then dye penetration method. Dye penetration method, the workpiece which has to be tested is cleaned first, and after cleaning it, penetrant is applied and allowed to penetrate deep inside the cracks available in the workpiece. Once the penetrant penetrates deep inside the workpiece, developer is applied. Developer helps in absorbing the penetrant and giving a good contrast, which will help in which will help in inspecting the workpiece and understanding where the cracks are present.
Mm-hmm. You missed so many things in ultrasonic and this one dye penetration test. Ultrasonic, you have to explain fully everything with the step by step. First, there will be a pulsar. The high that high frequency sound waves is sent through the pulsar. Pulsar, the high voltage and electrical pulse will be enters into the transducer. Then in transducer, high frequency ultrasonic sound energy will hits the discontinuity, or wherever the crack will be there, no, it will hits there. Then after that, part of the sound is reflected back. Then it is enters into the transducer. Then it will converts back into the this one reflected sound waves will converted into the convert back into the electrical signal. Then it is will be it will then electrical signal is displayed on the display unit or a receiver. So like this you have to tell each and everything perfectly. Okay. Then what you have told means high frequency sound waves is sent, and it is hits the discontinuity, and it will comes back. Then it will be, then you can see like that something you have told. No, you have missed
Past.
everything in between ka step. Only you have told overview of that. So you have to explain each and every step. In dye penetration testing, you have told that you will clean the surface, you will apply the penetrate or apply the dye, then you will remove the dye. After removing, then you will apply the developer. After you apply the developer, no, the spray layer, the developer, it will give the thin layer of the absorbs of the penetrant. Then the crack will be appeared by the red line at the last, means like wherever there will be a crack, no, there will be red line where it will come. Everything is there, means I have made this block diagram to make you understand. Wait 1 second. In my this one means it is difficult to by heart, no. So what I made is I did the this block diagram.
Yeah, I have.
Yeah, means but you made it, but you didn't by heart it, na. By heart it means like each and every step you have to tell. You missed most of things. Okay.
Okay.
Then difference between the centrifugal pump and a positive displacement pump.
Yes.
Yeah, tell.
Centrifugal pump works on the centrifugal pump work on the rotodynamic principle. Difference between centrifugal pump and positive
Positive
displacement.
displacement pump.
Centrifugal pump works on the principle of rotodynamic principle. The positive displacement pump works on the uh, positive displacement principle. Centrifugal pump requires priming. Positive displacement pump doesn't require priming. Centrifugal pump have low pressure, high discharge flow, and in positive displacement, it has high pressure, low discharge flow. The centrifugal pump have
Positive
irregular,
displacement pump discharge will be constant.
high pressure,
That is why
constant
it is
discharge.
discharge will be constant, because that is why we will call it as a positive displacement pump, right?
Centrifugal.
Yeah. Next.
Centrifugal pump, with the help of centrifugal pump, we can pump only water. In positive displacement pump, high viscous as well as low viscous fluid can be pumped. In centrifugal pump have high efficiency. Positive displacement pump have low efficiency. The centrifugal pump, the moving part in a centrifugal pump is a impeller. The moving part in a positive displacement pump is gear, uh, lobe, screw.
Gears only, no? Moving part.
Only gears.
Gear only will be moving, right? Yeah.
No, in only that is enough.
Means the positive displacement pump, if I tell, you should remember the gear pump and screw pump. Okay. Only both. Don't confuse it with the reciprocating pump. It is categorized in that, but actually it is a reverse piston movement principle. If you Google it also, it will come as reverse piston movement, not a positive displacement. Okay. Then the difference between centrifugal pump and reciprocating pump.
Centrifugal pump works on rotodynamic principle. Reciprocating pump works on the reverse piston principle. Reverse piston movement principle. Centrifugal pump requires priming, and reciprocating pump doesn't require priming. In a centrifugal pump, the moving part used is an impeller. In a reciprocating part, moving in a reciprocating pump, moving part used is a piston cylinder arrangement. In a centrifugal pump, the flow rate is constant. In a reciprocating pump, flow is fluctuating.
Hmm.
In a centrifugal pump, the less viscous fluid can be pumped. In
Hmm.
a reciprocating pump, high viscous fluid can be pumped. Centrifugal pump have high efficiency. Reciprocating pump have low efficiency. Uh,
Yeah, that much only enough. Okay, and a reciprocating pump and gear pump, can you differentiate?
Reciprocating pump work on the principle of reverse piston movement.
Hmm.
Positive displacement pump works on the positive displacement principle.
Hmm.
In a
Reciprocating pump
reciprocating
and gear pump, I told. Gear pump works on the positive displacement principle, like that.
gear pump work on the positive displacement principle.
Yes.
Recipro Reciprocating pump has a air vessel fitted on it
Mm-hmm.
at the inlet and outlet side. In
See,
a gear pump,
that one air vessel is not a necessary thing to put. Okay, some people will put, but we will mostly use it to convert the fluctuating flow into constant flow. Because of that, if you tell the air vessel, no, you should tell that to maintain the constant rate, air blower is used to maintain the constant flow rate.
air blower or air vessel, both are same.
Air vessel is proper. Sorry, air blower, air vessel. Okay. Uh,
In a gear pump, there is no
no
air vessel
required because
fitted,
it works on the
no
positive
report. It
displacement principle,
positive
like
displacement.
that. Okay.
In a mm, in a reciprocating pump, no pressure relief valves are used. In a gear pump, pressure relief valve are used. In a in a reciprocating pump, the volume inside the casing is more. In a gear pump, the space inside the casing is less. Gear pumps are high efficient. Reciprocating pump are less efficient, less efficient.
Are you sure about this point? Gear pump is more efficient and reciprocating.
ಹ್ಮ್.
If
ನಿಕ್ಕೋರ್ಲಿ ನಾವು ಇದಕ್ಕೆಲ್ಲ
if you are not sure, no, don't tell. If
ಓಕೆ
you are
ಓಕೆ
sure, no, then only you will tell. I also don't know that gear pump is more efficient or reciprocating pump more efficient. Okay. If you are sure, if you have researched about it, then you tell. There is no issues. If he ask, he will also ask means like, are you sure about this? Karke. Then you should not means like not be confused. You should not tell like I know I am not sure like that. If you are sure, then you tell. Okay. Even I also don't know which one is more efficient. I have to search it. Okay. Then next point.
gear pump has a moving part as gears. In a
Hmm.
reciprocating pump, the moving part is used as a piston.
Hmm.
Reciprocating pump have irregular or have irregular flow rate.
Hmm.
In gear pump, there is a constant flow rate.
Hmm.
Yes,
Fluctuating flow will be taking place in reciprocating.
irregular fluctuating.
Fluctuating, you use the word fluctuating. Okay. Okay. Then you know what is reflection and refraction?
Reflection.
Yeah, tell me.
Reflection, when a light rays hits it's a particular body
Hmm.
and it bounces back, it is called as reflection.
Hmm.
Refraction is when a light rays move from uh, different density medium, there will be change in direction of the
Hmm.
light rays.
Yeah. Yeah, this much is enough. Okay. And this much only he will ask actually. To give the feedback, you know very well where all the mistakes are there. Just improve it. Okay. Okay, bro.
Okay,
Bye.
thank you.